After studying this module, you shall be able to know the detailed theory behind Flory's principle, evaluate weight average molar mass and number average molar mass, compare number average molar mass and weight average molar mass, comprehend polydispersity index. Polymers are the non-homogeneous substances which contain mixtures of chemically similar molecules which are different in size and distributed around an average. Various theories have been developed to calculate the average molecular weight distribution of the polymer. One of the theory is Flory's theory. This theory is discussed in the next section. Flory's theory was developed by Paul Flory. The conclusions of Flory's theory of weight distribution function of polymers is resulted from various theory of linear polycondensation. The determination is based on the three postulates. 1. Reactivity of the functional groups of the polymer does not depend on the size of the molecules to which they belong. 2. During the reaction, the bonds which are newly formed have the same resistance to the reverse reaction. 3. There will be no side reaction or cyclization. We should note that the first postulate does not get violated due to the external factors such as viscosity of the solution, because kinetic limitations due to this factor apply equally to all groups. Considering the assumptions of this Flory's theory, we have number average molar mass Mn bar and weight average molar mass Mw bar are to be determined by this theory. This theory is valid only to linear polymerization and not to branch polymerization. There is no loss of mass during this polymerization, that is, linear polymerization is assumed to be addition polymerization and not the condensation polymerization. As it is linear addition polymerization with no loss of mass, weight of the imer is I times the weight of the monomer. That is, M1 is equals to M naught, M2 is equal to twice M naught, M3 is equal to thrice M naught. Therefore, Mi is equals to I times M naught. This is our equation 1, where I is the degree of polymerization and M naught is the weight of the polymer. Total number chains of all types will be given by N1 plus N2 plus N3 up till Ni equals to N. That is, summation Ni is equal to N, equation 2, and summation I times Ni is equals to N naught. This is our equation 3. The probability of formation of chain with I number of monomers, that is P function of I and P, is derived as below. Let P be the probability that reaction has occurred to link two adjacent monomeric segments. Then 1 minus P will be the probability when no linkage has occurred. Consider when one monomer unit reacts, that is I is equal to 1, then P 1P is equal to P to the power 0 into 1 minus P to the power 1. As in one single unit there cannot be any bond formation, therefore, P to the power 0. When two monomers react, that is I is equal to 2 and number of bonds formed will be 1, therefore, it will be P to the power 1. Thus, we have P 2P equals to P to the power 1 into 1 minus P to the power 1. When three monomeric units react, that is I is equals to 3, then the number of bonds formed will be 2, therefore, p to the power 2, and p will be given by p to the power 2 into 1 minus p to the power 1. Therefore, we derive the general formula for the probability of polymers having the chain length I, which is given by p as a function of I and p is equal to p to the power I minus 1 into 1 minus p to the power 1. This is our equation 4. The probability of formation of polymer having I units is also given by p equal to number of chains of I type divided by number of chains of all types, which can be further written as equal to Ni by n. This is our equation 5. Since the total probability of polymer formation is always equal to 1, therefore, the summation of equation 5 should also be equal to 1. That is, summation of p as function of I and p equals to summation p to the power I minus 1 into 1 minus p to the power 1 is equal to 1 minus p to the power 1 times summation p to the power I minus 1 is equal to 1. Considering the left hand side, we have 1 minus p into p to the power 0 plus p to the power 1 plus p to the power 2 plus p to the power 3 plus so on, which is equal to 1 minus p into 1 plus p square plus p cube plus so on. Using the binomial expansion, 1 plus p square plus p cube plus so on is equal to 1 minus p to the power minus 1. This is equal to 1 minus p into 1 minus p to the power minus 1, giving equal to 1. Hence, the total probability is equal to 1. Now, we shall see the determination of number average molecular weight. Number average molecular weight Mn bar is given by Mn bar equal to summation Ni Mi by summation Ni. This is equal to summation Ni Mi divided by n, which can be written as summation Ni by n times Mi. This is our equation 7. Substituting the equation 5 in equation 7, we get Mn bar equals to summation p as a function of I and p into Mi. This is our equation 8. Substituting equation 6 in equation 8, we have Mn bar equals to summation p to the power I minus 1 into 1 minus p into Mi. This is our equation 9. Using the arithmetic progression, this can be written as equal to 1 minus p summation I p to the power I minus 1 m naught, or this is equal to 1 minus p times m naught summation I p to the power I minus 1 equal to 1 minus p into m naught into 1 p to the power 0 plus 2 p to the power 1 plus 3 p to the power 2 plus 4 p to the power 3 plus so on up till I p to the power I minus 1. This is our equation 10. From the binomial expansion, we have 1 p to the power 0 plus 2 p to the power 1 plus 3 p to the power 2 plus 4 p to the power 3 plus so on up till I p to the power I minus 1 is equal to 1 minus p to the power minus 2. Substituting this, we get Mn bar equals to 1 minus p into m naught into 1 minus p to the power minus 2. Therefore, Mn bar is equal to m naught divided by 1 minus p. This is our equation 11. If p is 0, this implies Mn bar equals to m naught. That is, the extent of polymerization is 0, which means that the sample is a monodisperse sample. Now, we shall see the determination of weight average molar mass. weight average molar mass is given by mW bar is equal to summation Ni square divided by summation Ni. This is our equation 12. Dividing numerator and denominator by n, we get mW bar equals to summation Ni by n into Mi square divided by summation Ni by n into Mi as our equation 13. Substituting the value of probability, that is equation 5, in this equation, we get mW bar equals to summation p into Mi square divided by summation p into Mi as our equation 14, which can be further written as summation p to the power I minus 1 into 1 minus p into I square m naught square divided by summation p to the power I minus 1 into 1 minus p into I m naught as our equation 15. This can be further simplified as m naught into summation I square p to the power I minus 1 divided by summation I into p to the power I minus 1 as our equation 16, which can be further simplified as m naught into 1 plus 4p plus 9p square plus so on divided by 1 plus 2p plus 3p square plus so on as our equation 17. And therefore, mW bar is equal to m naught into 1 plus 2p plus 2p square plus 2p cube plus so on as our equation 19. Adding and subtracting 1 in the above equation, we get mW bar equals to m naught into 2 plus 2p plus 2p square plus 2p cube plus so on minus 1, or this is equal to m naught into 2 into 1 plus p square plus p cube plus so on minus 1. Using the binomial expansion, we get mW bar equals to m naught into 2 by 1 minus p minus 1. This is our equation 20. This gives mW bar equals to m naught into 1 plus p divided by 1 minus p. This is our equation 21. On a similar basis, weight fraction of I moles is determined by the following formula as Wi equals to n naught into 1 minus p square into p to the power I minus 1 into I divided by n naught, which can be further written as equal to 1 minus p whole square into p to the power I minus 1 into I as our equation 22. Now, we shall see the comparison between Mn bar and Mw bar. According to Flory's theory, Mn bar is equal to m naught divided by 1 minus p, and Mw bar is equal to m naught into 1 plus p divided by 1 minus p. Thus, ratio of weight average molar mass to number average molar mass can be written as Mw bar by Mn bar equals to 1 plus p. This is our equation 23. Since p is the probability of bond formation, it always ranges between 0 to 1. Case 1. When p is greater than 0, the above ratio, that is equation 23, will always be greater than 1. Hence, Mw bar will be greater than Mn bar. Case 2. When p is equal to 0, that is no bond formation is taking place, then Mw bar is equal to Mn bar. It means Mw bar is equal to m, that is the molar mass of the polymer. Hence, the extent of reaction will completely determine the molar mass of the polymer. Now, we shall study about the polydispersity index. Polydispersity index is a measure of the distribution of molecular mass in a given polymer sample. The polydispersity index is given by the ratio Mw bar divided by Mn bar equals to 1 plus p. Here Mn bar stands for number average molar mass, which is more sensitive to molecules of low molecular mass, while Mw bar stands for the weight average molar mass, which is more sensitive to those molecules which have higher molecular masses. Since P ranges between 0 to 1, therefore, PDI ranges between 1 to 2. Now, we shall summarize what we have learnt in this module. Polymers are the non-homogeneous substances which contain mixtures of chemically similar molecules which are different in size and distributed around an average. Flory's theory is one of the theory for determining the average molecular weight of the polymers. Flory's theory was developed by Paul Flory. The probability of formation of polymer having I units is also given by P as a function of I and P equals to number of chains of I type divided by number of chains of all types equals to Ni by N. Number average molar mass Mn bar and weight average molar mass Mw bar has been determined by this theory. Number average molar mass is given by Mn bar equals to summation Ni Mi by summation Ni, and Mn bar is also written as M naught by 1 minus P, where M naught is the weight of the monomer. Weight average molar mass is given by Mw bar equals to summation Ni Mi square by summation Ni Mi, or this can be written as M naught into 1 plus P divided by 1 minus P. Polydispersity index is represented by the following ratio of Mw bar by Mn bar equals to 1 plus